Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss graphs of piecewise function, that is greatest integer, signum, least integer, and various other functions. In the previous session we have discussed the graph of rational and irrational function. Right? So let's begin this session. Now friends, in the previous session we discussed the graph of a straight line, that is y is equal to x. We call that as identity function, or it is a straight line that is passing through origin. Now this is what y is equal to modulus of x, right? Now modulus function, that means the value of y will always be positive, whether it is x is positive or negative, y will always be positive, right? So the graph will be on the upper side of x-axis only, right? If x is 1, y is 1. If x is 2, y is 2. X is 3, y is 3. If x is minus 1, still y is 1. If x is minus 2, still y is 2, right? So we are going to get a straight line that will be passing through origin in the first quadrant. Similarly, we'll be getting a line that is passing through origin in the second quadrant. So finally, we get a shape of V over here as the graph of a modulus function, right? Now, what will be the domain? You can have any value of x, that means domain will be R, right? After that, if x is 0, y is 0, that means the graph will pass through origin. Apart from that, range, if we talk about whether x is positive or negative, y will always be positive, right? So range will be positive real numbers as well as 0, because when x is 0, y is 0, right? So this is this sort of graph we are going to get, domain and range. Nature, f of x is equal to f of minus x, because if you put x as minus x, still you'll be getting the value as y, right? So it's an even function, right? F of 2 is also 2 and f of minus 2 is also 2. That means f of x is equal to f of minus x, hence it is an even function, right? Now there are some important properties of modulus function that you need to keep in your mind. If modulus of x is less than equal to a, that means x lies between minus a to a, right? And provided a is greater than equal to 0, right? And if modulus of x is greater than equal to a, then in that case x is less than equal to minus a, or x is greater than equal to a, right? You don't have to be confused by looking at these properties. We will be discussing the problems based on these properties, so it will be clear to you at that time. Okay. Now modulus of x plus minus y is less than equal to modulus of x plus modulus of y, right? Similarly, this property. Okay. Now remark, it represents two lines. This angle is 45 degree with the positive x-axis, and this complete angle is 135 degree with positive direction of x-axis. Okay, this angle will be 90 degree. This is 45 degree. This is also, if we take it from negative x-axis, this will also be 45, right? So this complete angle is 180. So this part will be 135 degree. Okay. Now friends, we have very important function or graph over here, that is fx is equal to, we can say box x, or it is greatest integer function, right? Y is equal to box x. Now what is that? It's the greatest integer among all integers which are smaller or equal to x. Suppose if we take box of 2.3, that will be 2. That is we just have to take the integral part of that, right? 0.99 integral part is 0. If we have negative numbers, suppose minus 2.99, then the integer that is the biggest integer that is less than minus 2.99 is minus 3, right? So box of minus 2.99 is minus 3. Okay. Now this graph is going to be very important, as frequently the questions based on greatest integer function are part of competitive examinations. Okay. Now here domain is R. Now what will be the range? Because we are just taking the integral part outside. If we solve this function, So range will always be positive number, integral values, right? We can see from here it's 2, 0, -3. So range will always be set of integers. Okay. Neither even nor odd function, because f of x is not equal to f of minus x or not equal to minus f of minus x, right? So it is neither even nor odd function. Now let's see how do we draw this graph. Now friends, if x is 0, y is 0. That means what is happening over here? The graph will pass through origin. So this is the point from where the graph starts. Now up to 0.9999, immediately less than 1, the value of this box function will be 0, right? So till 1 the value will be 0. So till 1 the value will be 0, right? Whether you put it is 0.1, 0.2, 0.3, whatever value you put, less than 1, fx will be 0. Okay, so we are going to get a line that is like this, right? Now what happens at x is equal to 1? Immediately before 1, the value of fx is 0, and exactly at 1, f1 is 1, right? That means box 1 will be 1 only. So exactly at 1, f1 will be 1, right? So this is the point. Now this the circle that you are seeing over here, it's actually the part of the graph that is not included, right? Because we cannot show on the graph the value that is immediately less than 1, right? So what we show over here, that this point is not on the graph, right? As whenever it becomes f1, the value of f1 will be 1 only. The graph shifts over here, right? Now from f1 to f2, that means if x is greater than 1 and less than 2, further we'll be getting a straight line that is parallel to x-axis, right? From 1.000 to 1.9999, the value of box x will be 1 only. Okay, so further we'll be getting a straight line. As it becomes f2, the value will be 2 only, right? f2 will be 2. That means box 2 is 2. Similarly, we can proceed further. So the circles you are seeing over here are not the part of the graph, but we cannot show the immediate smaller value. That's why we are using these circles. Okay. Now here we can see on the negative side, from 0 to -1, suppose we have f of say or a box of, we calculate minus 0.1, then the value of this will be -1, right? So till -1 will be getting the values as -1, right? And f of -1 will also be -1. Okay. After that, if it is -1 point something, then it will be shift to -2. If it is -2 point something, it will be shift to -3, right? Similarly, the graph will proceed. So we are going to get the lines, straight lines, which are parallel to x-axis. So this is going to be an important function that you should keep in your mind. Now discontinuous, that means the graph is not continuous. You can see the breaks. That means if you are going to draw the graph, you need to take out your pen, right? If I draw the graph, I take out my pen, then I draw the other line, I take out my pen, then I draw the other line. That means it is a discontinuous graph, right? This sort of graph like this, these are continuous graphs, but this graph is discontinuous. So greatest integer function is an important function, okay? And you should be clear, box of 2.3 is 2, 0.99 is 0, and if we talk about the negatives, then it goes down, right? And this is known as the fractional part. So precisely a function, a number is sum of integral plus fractional part. Obviously. Similarly, we have least integer function, that is, we represent it like this, bracket x, suppose I name it. So is the least integer among all integers which are greater than equal to x, right? So 2.3, if it is written like this, so immediately bigger integer than 2.3 is 3, right? Immediately bigger than 0.99 is 1. Immediately bigger than minus 2.99 is minus 2, right? So the graph we draw over here is quite similar to the graph of the greatest integer function. The only difference over here is from minus 1 to 0, the graph will be, suppose it is minus 1, then it will be minus 1. But if it is say minus 0.99, then it will be 0 only, right? So you can see very well from this graph, from this line. Still we'll be getting the lines parallel to x-axis, and these circles are not the part of the graph, right? For the same reason that we have discussed earlier. Now domain is R because you can choose any value of R. Range will be set of integers obviously because it is an integer function. Nature neither even nor odd because f of x is not equal to f of minus x and f of x is not equal to even minus f of minus x, right? Further, the function is discontinuous, that we can very well see because if I draw this graph, I need to take out my pen. Okay, so we have discussed two functions, that is greatest integer function and least integer function. I just write greatest integer. In the case of greatest integer function, it will be 2. In the case of least integer function, it will be 3. So that is precisely the difference. Okay. Friends, similarly, we have fractional part of a function. For any suppose x we have, it's greater than equal to box x, right? If and the difference between the number x and its integral value is called the fraction part of x, right? That means x is equal to what? Box x plus fractional part of x, or if we wish to define fractional part of x, that will be x minus box x, right? Now fraction part lies between 0 to 1 obviously, okay, because any fraction is greater than equal to 0 and less than 1, not equal to 1 but less than 1, right? So fractional part is greater than equal to 0 and less than 1. Okay, I just can take an example over here. 2.3 is equal to 2 plus 0.3. That is the integral part, that is the fractional part. Okay. So friends, in the next session, we'll be taking more graphs. Do revise this session and the previous one. As I have already told you, were very important from the competitive examinations point of view, right?